Alright, so we're going to start our next unit reviewing a little bit of stuff that you learned back in grade 10, and the whole idea of expanding and simplifying polynomial expressions. So as a bit of recap from grade 10, if you're looking to multiply different polynomials, so for example, let's say we were trying to multiply 2x plus 3, and we're trying to multiply that by x minus 6. We actually had a couple different approaches we used to actually help us multiply those. So one way was just use the distributive property. So distributive property meaning that we're going to take 2x plus 3 and distribute it through that second bracket, so multiply it by x and by minus 6. So in that case you would have x, and that would be multiplied by 2x plus 3. Okay, and then of course the next term in the second bracket is going to be minus 6. So you'd have minus 6, and again that would be multiplied by 2x plus 3. And at this point what you then have to do is then just continue expanding and simplifying. So multiply the x through this bracket, 2x plus 3, and the minus 6 through this bracket, 2x plus 3. And you'd wind up in this case with 2x squared plus 3x from this multiplication. Over here you would get minus 12x and then minus 18. All I'll really be left to do at this point is to then collect your like terms. So the 2x squared is the only squared term you have. You have plus 3x minus 12x, so minus 9x, and then of course minus 18. Okay, so that was using the distributive property. Now, depending on how you were taught in grade 10, you probably did a lot of questions this way, or you might have used something called an array. So remember, to use an array, we do this exact same problem and set up a 2 by 2 grid. And why is it 2 by 2? Because, well, 2 terms in this polynomial, 2 terms in this polynomial. So you'd set up a little bit of an array here and put your two brackets, your two polynomials on the outside. So you have 2x plus 3 out here, and then x minus 6 out here. And you'd fill in each box inside the array using multiplication. So up here in the top left you have x times 2x, so you would get 2x squared. 3 times x is 3x. 2x times minus 6 is minus 12x. And then minus 6 times 3 is minus 18. And you'd see that the terms in here, 2x squared, 3x minus 12x minus 18, are the exact same terms we got here from using distributive property, but it's a nice, more visual way. And I actually prefer using arrays because when the polynomials get more complicated, as you'll see later on in this lesson, it becomes a lot easier because you can visually see each term that needs to be multiplied together, whereas using distributive property, it's easy to miss a term or two. So again, this one just simplifying to 2x squared. 3x minus 12x gives me minus 9x, and I get the minus 18. Okay, so those are the two methods that you really looked at last year to multiply polynomials together. Okay, so one thing you can do to always help making the multiplying by polynomials with arrays even easier, just so the like terms always along a diagonal, you can arrange both polynomials in standard form, so descending order of power. So if they're not already in standard form, sometimes it helps to do so. And again, this is just an option. Or you can use a placeholder if required. So if there's no x squared term in the cubic, like let's say for example you had 3x cubed plus 2x minus 6. You see there's no x squared term in here. You may find it easier to add in a 0x squared. It makes your array larger, but it does mean when you're simplifying afterwards that all your like terms will be along a diagonal. Now this is completely optional. A lot of people won't do that step, but if you find it helpful, then by all means go for it. So this particular one, you can see how quickly multiplication of polynomials using arrays can get pretty large. But this question is a lot easier with arrays than it is using distributive property. So I want you guys to try this on your own. The answer is here. And the only difference is you're setting up an array. Instead of 2 by 2 like the example we did on the last page, our first polynomial is 3 terms. So we have 3 rows here. Our second polynomial is 4 terms. So we have 4 columns here. So what we wind up with is a 4 by 3 array. Okay, so using your array here, try and fill in each box inside here and see if once you simplify all your like terms, that you wind up getting this this answer up here. So give that a try for a couple minutes, and if you get it, you can move on to the next example. Otherwise, when you push play, we'll go through it together. Okay, so you can see here what the inside of the array should look like. The big thing to watch out for here when you're doing this multiplication, for each step here, just make sure you're following your exponent rule. So for example, up here, 4x cubed times 3x squared, x cubed times x squared, remember from grade 9, if your multiplying powers are the same base, you add the exponents, you get x to the exponent 5. The other thing that also is a common mistake of doing this multiplication are just little sign errors. So here, for example, negative 5x times negative x squared would give you positive 5x cubed, and so on and so forth. So you can see nicely here all the like terms are along diagonal. So you can add your x to the fourth terms, your x cubed terms, your x squared terms, and so on and so forth. And you should wind up with this one right here. Okay, so by comparison, if you're trying to do this exact same example using the distributive property, what you'd have to do is then distribute each term from the first bracket into the second bracket, or vice versa. And you can see that it still works, right? If you were to continue this on, you'd multiply 3x squared through all this, minus 5x through all this, and plus 2 through all this, and then collect your like terms. You'll eventually wind up in the exact same place. But you can see that it just takes several lines of algebra, and having the array here just makes it a lot easier because you're less likely to make a mistake. You're going to see every term that you need in front of you. Okay, with that in mind, let's try a few more complicated examples. Okay, so here's what I'd like you to try. So again, the answer is here for you, so you can check to make sure you're getting it right. What I'd like you to do is take 3x squared plus 1 multiplied by 2x squared minus 5x minus 7. Using the method of your choice, I would strongly suggest using an array. So give that a try, and let's see what you get. Okay, so we can take a look at what's inside the array here, and hopefully when you see, once you check it and you go through all the like terms and being simplified, you wind up seeing that the only simplification you really have to do is the minus 21x squared plus 2x squared to give you the minus 19x squared. Other than that, you just wind up with 6x to the fourth minus 15x cubed minus 19x squared minus 5x minus 7. Okay, let's try another one. Okay, so here's what I'd like you to try, again, on your own. So give it a shot, see what you get, and when you're ready to see the answer, push play and we'll go through it together. Okay, so take a quick look see here what the final answer is. You get x squared plus 32x plus 40. Before I go into each step, the most common mistake that people make, especially when they see a binomial squared here, is just assuming that all you need to do is square the first term and square the last term. So in this case, you'd say that this whole thing is equal to 9x squared plus 25. That is 100% wrong. It's a very common mistake in grade 10. I still see it a lot in grade 11. We can't be making mistakes like that anymore. So remember this, okay? If you have a binomial that's squared, it doesn't mean you just simply square each term. You have to use an array to expand that out. So 3x plus 5 all squared is the same thing as 3x plus 5 times 3x plus 5, which in an array you can clearly see that's not just 9x squared plus 25. There's going to be a middle term here of 30x when you put those two 15x's together. So please do not make that mistake. It happens a lot, and it usually leads to further mistakes down the road when you make a mistake expanding and all of a sudden the resulting equation doesn't simplify properly. It just leads to messes. So please make sure you don't make that mistake. So you expand these two using an array to get 9x squared plus 30x plus 25. You expand the 2x minus 3, 4x plus 5 using an array to get 8x squared minus 2x minus 15. So the other mistake that I see often a lot here is you see how this there's a subtraction here. Remember that this subtraction applies this entire multiplication that's taken place. So this negative sign will apply to everything that's there after you've done the multiplication. So it means it doesn't just apply to the 8x squared, it applies to the minus 2x and the minus 15. So it distributes through, and you get minus 8x squared plus 2x plus 15. So once that's done, you can simply collect your like terms, and you get x squared plus 32x plus 40. Okay, so this next one here, last one I'll have you try for now. You can see it's a bit more complicated. Now over here, starting with the right half of this expression, you have an x minus 4 times 2x squared plus x minus 6, and there's a times 3 in front. And now over here we have an x plus 2, 2x minus 3, x minus 4. One thing I'd like to point out is that the order of multiplication does not matter. So if I wanted to, I can multiply the 3 times x minus 4 first and then multiply it by the 2x squared plus x minus 6. Or I could start with the brackets and then multiply by the 3. Similarly over here, I can choose any pair of these a pair of binomials here to multiply through first and then multiply by the remaining one. I can't do it all at once. There's 3 multiplications for each one. So you have to start by multiplying 2 together and then multiplying what you get for the result times the third one. So what I chose arbitrarily over here is to choose 2x minus 3 times x minus 4. So the second two terms to multiply, the second two binomials to multiply first. Again, you can choose a different 2 to start with, and if you do, just make sure you get the same answer in the end. I personally, for the second group over here, will choose to multiply these brackets together first, only because I like to deal with as small numbers as possible inside the array. So if I multiply the 3 inside one of these brackets first, and all of a sudden numbers in my array get larger, I may be more likely to make a mistake. So I'm going to start by filling in these arrays here. So I'm going to get 2x squared minus 8x minus 3x plus 12. And over in the second multiplication here, I'm going to get 2x cubed plus x squared minus 6x. Down here for the bottom row, I get minus 8x squared minus 4x and plus 24. So once I simplify what's inside the array here, I get 2x squared minus 11x plus 12, so you can see that over here. And I get 2x cubed minus 7x squared minus 10x plus 24, which I see over here. Okay, so what I'd like you guys to do now is take this from here and finish it, take it to its completion, and see what you get for final answer, and push play and you're ready to go through it. Okay, so take a minute and check your answer there. So for that first multiplication here, you should get 2x cubed minus 7x squared minus 10x plus 24. And if you can't get that to work, check with a friend or come see me. I'll walk you through the array. And then for the second part right here, just multiplying the minus 3, distributing it through this entire bracket here. So remember the negative distributes as well, so you get negative 6x cubed plus 21x squared plus 30x minus 72. Collect your like terms, you wind up with this final answer right here. Okay, the last thing I'll mention in this lesson is the whole idea behind equivalent expressions. So you can consider expressions equivalent if all the following conditions are satisfied. So algebraically they have to be exactly the same. They have to be the exact same expression. So meaning when you simplify them, they should be identical equations. It also means that for every value of x, you produce the same value of y. And it also means they produce the exact same graph with no exceptions, no slight differences at all. So let's take a look at our last example. So we had this guy right here, these x plus 2, 2x minus 3, x minus 4, minus all that other stuff. So we had this for original expression. We simplified it into this. So in theory, these should be equivalent, right? When we use algebra to expand and simplify this, we got a different expression, but in theory, these should represent the exact same graph. So let's take a look at that and confirm that. So taking a look on Desmos here, so see I first have the original expression we started with, and then for I have g of x, I have the simplified version. So let's see what happens when I put them on a graph. So I put up f of x on a graph, you can see it looks like this. And if I put g of x on the graph, you see it looks essentially the same. And you see if I try and plot them together, they just wind up overlapping each other. Okay, so algebraically, not only do they look the same, as one simplifying to the other, but they produce the exact same graph. So every x value on f of x produces the same y value on f of x as it would on g of x. So these functions are considered to be equivalent. Okay, if there was any difference at all between them, either algebraically or graphically, then they would not be considered equivalent. Okay, so that's it for this lesson. Again, there's a lot of algebra in this unit, so it's really important to make sure that we develop those skills and that we're able to do them not only correctly, but eventually efficiently and with speed as well. So please make sure you do the practice, and it'll set you up nicely going forward in this unit.